concentration of solution. Concentration of solution. So how can we calculate the concentration of solution? Mainly by using three equations, right? So we can write this equation like this: mass by mass percentage of solution. Mass percentage of solution. Second type equation is mass by volume percentage of solution. Volume percentage of solution. Third one is volume by volume percentage of solution. Percentage of solution. So here we can say it like this: mass by mass percentage of solution, right? So mass of solute by mass of solution into 100. This equation can be applied for the solid solution, right? So in that, solute particle is solid in solid state, solution is in solid state. So in solid solution we can apply this equation: mass by mass percentage of solution, that is mass of solute by mass of solution into 100. And in the second type, mass by volume percentage of solution, right? So here we can say that mass of solute divided by volume of solution into 100. So this type of equation we can apply for liquid solutions, right? So that is we can take the example as salt solution and sugar solution. In that, solute particle is actually in solid state, solid phase, right? And the solution is liquid. Okay, so for such type of solution, liquid solution, we can apply this equation: mass by volume percentage of solution. Mass of solute by volume of solution into 100. That means in case of salt solution, the mass of salt divided by volume of salt solution into 100. Okay, in case of in this solid solution, we are applying this equation here. Mass of solute is what? Zinc. Mass of zinc by mass of brass into 100. In case of brass alloy. Okay, so in this equation, volume by volume percentage of solution, what will be the equation? Volume of solute divided by volume of solution into 100. Solution into 100. That is, both solute and solution will be in liquid state or in gaseous state. So in case of gaseous state also we can apply this equation. In case of liquid also we can apply this equation. Okay, so that's about the concentration of solution. The equations to calculate the concentration of solution. Okay, so that's about this equation. So if you are not at this one, I am rubbing this. And the next one is Tyndall effect. Next one is Tyndall effect. Tyndall effect. Okay. So if you are taking solution, colloid and suspension. Okay. Solution, colloid and suspension. So in this container we are taking salt solution. Example is salt solution. Here we are taking example as milk. Here soil solution. Okay. So here the particle size is small. Okay. Here the particle size is larger. And we can't distinguish the solute particle within the solution. That means particle size is less than 1 nanometer. Here particle size is in between 1 and 100 nanometer. Here particle size is greater than 100 nanometer. Okay. So when we are passing a beam of light through this solution, what will happen? The particle size within the solution is less than 1 nanometer, right? So we can't distinguish the particle by naked eye. And if you are passing a beam of light through the solution, we can't separate, we can't see the particles within the solution. That means the beam of light is invisible in case of solution. And when we are passing the beam of light through the colloid solution, what will happen? We can see these particles. We can see these particles within this colloid. Okay. So because the particle size is actually in between 1 and 100 nanometers. So the beam of light is visible in case of colloids. And when we are passing a beam of light through the suspension, example is what? Soil in water. That means soil solution. Right. So these are larger particles to represent soil. And the particle size within the suspension is greater than 100 nanometer. So we can actually see the particles if we are seeing through the naked eye. Okay. So then again when we are passing beam of light through the suspension, what will happen? The particles are clearly visible. Now the particles are clearly visible in case of suspension. Clearly visible. And when we are taking the case of colloids, we can't see the particles within the milk, right? We are taking milk as an example, and when we are seeing through the naked eye, we can't see the particles, right? So when we are passing a beam of light through this colloid, we can actually see the particles within the colloid. So that's all about the Tyndall effect. So what is Tyndall effect? The passing of a beam of light through these substances, and if that light beam is scattering or not. So when we are taking this colloid and suspension, actually the light beam is scattered by the particles of this colloid and suspension. So this effect we can call it as Tyndall effect. The scattering of a beam of light by the particles of colloid and suspension, we can call it as what? Tyndall effect. Okay. So that's all about the Tyndall effect. That is actually by the difference in the particle size of the solution, colloid and suspension particles. So thank you.